Hello friends, welcome back. So today we are starting a new topic in our lecture series on data structures, and that is queue. So these are the things that we are going to cover, and today we will start with the introduction or the features. So first of all, I would like to tell you in the introduction what is a queue and how basically you can visualize it. So as the name suggests, a queue is something that we generally face in everyday life. Whenever you are in a line in a bank or anywhere, you stand in a queue, right? So a queue, there is something called back, where every new element or every new, if you are talking about the queue of a bank, will come into, right? So we can say that from the back here, new element will be inserted, right? And there is something called front, where you will say the element will be taken out, right? And here between we can say there would be various elements. Depending on which type of implementation we are using, there can be a static queue, which means its size is fixed, or it can be a dynamic one, which can say its size will keep on increasing or decreasing as we go along depending on number of elements. Okay, so you can see that the person who went into the queue from here will be the first person who will come out of the queue from the right side or from the front side. So we can say that it is based on only one principle, or you can say there is only one feature, which is known as first in, first out. That's the only feature, only principle of queue. If you remember stack, it was last in, first out. Queue is the reverse one, first in, first out. Okay, so just keep the visualization of any queue in, for any bank line or any other purpose in your mind, and just try to see, okay, whoever was the first one who went into the queue will be the first one who will come out of the queue. Okay, so that is the only feature of a queue. So we have covered the introduction and features. Let's move towards what are different operations that can be there for a queue. Operations for a queue. Okay, the first one is push. That means inserting a new element in the queue. This will always be from back. Okay. Second will be pop. It is removing an element from the queue, always be from front, right? So first point says insertion will be from the back, and second point says pop will be from the front. Okay, so if I can write here, we can say we push from here and we pop from here. Third point is Like we have top or peak in case of stack. Here we have peak or front. We do not have top here. Okay, so we can see that see or get the element in the front. Few implementations can have back also, but in case of a typical queue, you only see what is at the front. Okay. In case of extended implementations, we can have, okay, you can pop from back also, but we will talk about that later when we talk about the specific queues. But in a typical queue, these are the operations. And the fourth one will be isEmpty. And fifth could be isFull. Okay. So you can check that these would be depending on the implementations. But isEmpty, you want to, if queue is empty and if queue is full. So isEmpty, you are going to check when you would be doing a pop or front. Before that, you should check whether the queue is empty or not. Otherwise, you might get a runtime exception. And isFull, you want to check when you're doing a push in case of array-based implementations. If you have a linked list based, then basically you can extend till the memory of your operating system allow you to keep inserting new elements. Okay, so these are the operations we can have for a queue. We will see them more when we have a example. Then we will see more of these in the action. So if I can go back to what we need to cover, we have done operations. Let's move. What are different queue applications? Queue applications. Obviously, in the computer science world, that's what we are learning. It is widely used in caching algorithms. LRU, LFU. This stands for least recently used, least frequently used. Okay, I'm not going into detail. Maybe I need to have a different video to explain how these work. They employed more data structures, but queue is an integral part of both of these algorithms. Another one is, you can say, CPU scheduling. So how your CPU schedules various processes, which one to run, say round robin algorithm or such different algorithms, they also make use of queue. If you take your example of printer spooling, so if you have a shared printer in your office and many people are giving commands, so you can say that they are also maintains a queue. Whoever given the command first will be executed first. Very common algorithm called BFS, breadth first search, is entirely based on queue. When we will cover those in graphs, we are going to cover what is BFS. So it makes use of queue. And on a side note, DFS, depth first search, it makes use of stack. Right? So we are going to see both of them in detail in coming videos. So these are few of the common applications. So with this, let's take a example where we can see how various operations of queue are going to perform. Okay, so we can say that let's see queues operations in action. Okay, assume you get a question in your exams that following operations are performed on a queue. So operations could be push 10, push 8, push 7, then peek, then pop, then pop, push, peek, push, and pop. So these two push should have some values, let's say 4 and 9. Right? So let's have a queue. This is our back. So we are going to insert from here. This is our front. We are going to pull out from here or pop out from here. So let's start doing the operations. First of all, we want to do push. So we will push 10. So we will push from this side. So I will write here so that I can push more elements whenever needed. Push here. Again 8, I will push here. Again 7, we will push here. So these 3 are done. Then we have to peek. So peek is done from front. So what I see at the front right now. So when we say peek, it would be 10. Peek is done. Then it's pop. Pop means removing from the front. So what I will do is I will remove this part from the front. Pop is done. Another pop. I will remove next item, whatever is there from the front. Pop is done. Now I push. So push has to be done from back side. So 4. Then peek. What do you see from the front? 7. Then again push. Okay, I will do that from the back side. Then pop. So when you pop, you will have to remove it from the front. So these all we covered. So this is our output because we have done 2 peek operations. One here and second one here. At these moment we saw what was at the front of the queue. And this is the current state of the queue. 2 elements are there in the queue right now. So size would be 2. So if question comes in your exam, what is the final size of the queue when these operations are performed? You can say the size at the end of these operations will be 2. And these 2 elements will be there. Okay. So that's all for this current video. Can say that we have covered quite a few topics that we planned. So these things we covered. In next one, I will talk about circular, double-ended and priority queues. As I mentioned in the introduction, these are the extended functionalities over a basic queue. So we will see how they will basically change or what additional functionalities they are going to provide to us. Thanks for watching. If you have any doubt, please let me know in the comments below and I will be happy to answer. See you again. Bye.